Ms. Sapkar here. We're going to talk a little bit today about fluvial systems, about river systems, and hydrology. Does anybody know the river that I am standing right in front of? Jonathan. Correct. This is the Monongahela River. What we're going to look at today are a few different processes of the Monongahela River. But first off, for your warm-up, I need everybody to just look at the river and observe the river for about 30 seconds. I need you guys to tell me some different characteristics of the river. Where does it bend? Why you think it bends? And what are the different processes? Where do you think it's the fastest at what points? Where do you think it's the slowest at others? Go ahead and take a few minutes to do that. Okay, so we've made our observations of the Monongahela River. One thing now we're going to look at is one big observation you were able to tell is that the river is not straight. It definitely curves. It definitely has a meander in the river. If you can tell, the river's coming from this side. It's going to meander around this bend and go back. Does anybody have any idea as to why this river would meander? Exactly, there's something stopping in its way. One big thing with fluvial processes is that it follows the path of least resistance. I'm going to show you an example of what a path of least resistance is now, and we'll be able to explain more about the meander. So class, I just talked about the path of least resistance and how rivers tend to flow in that path. This is our example as to how path of least resistance works. This jug of water, I'm going to pour it down the hill. You can see it's going to go in a straight pattern. I have a doorstop. I'm going to put this doorstop in the middle of my path of water. Pour it again. It's going to divert around the doorstop. This is exactly what's happening with the river. That body or that piece of land is diverting the water from the river around that piece of land. Path of least resistance. The water's going to take the path of least resistance around the doorstop. Remove the doorstop. It's going to go path of least resistance straight down the walkway. Okay, so we have now learned all about path of least resistance and why our river does go into a meander. Now we're going to talk about more the depositional environment of the river, as well as what parts of the river are going to be eroded. Okay? The main thing about depositional environments is things are going to deposit. We're going to have a lot of sediment and rocks depositing along this point in the river. Does anybody have any idea as to what part of the river would be the depositional environment? Jake? Correct. We're going to say the flat part of the river is the flat part of the landscape along the river is the depositional environment. What happens is as the river comes around the bend, it will deposit its sediment. That is the slowest point in the river is the inside of the bend. That also has a specific name called a point bar. So in scientific ways, our point bar is our depositional environment. That is why when you look at Cal U, which is the campus over there on the flat end, you will see that it is flat. Whereas on the other side of the river, it's a hill. Any ideas as to why it would be a hill on the other side? Good job, Rachel. On the other side of the hill, it is actually cutting into that bank. That would be our cut bank. Okay, now we're going to talk about forces of the river, the power of the river. We already talked about with our point bar that is the slowest point in our river as to why it would deposit our sediments. We talked about in the cut bank that being the fastest point of our river, which is going to erode parts of the hillside and erode our sediments on that side. Now, what do you think would happen if, since it is going to cut so far into the bank, into our cut bank, what exactly would happen then over a period of time? Kelsey. Exactly. It is going to cut through the land on that side. So what would we get? No, we wouldn't get a pond. Something bigger than a pond. Yes, great. We would actually get a lake. The term for that is called an oxbow lake. What would happen is since we have learned processes of fluvial systems, they follow in path of least resistance. So this river actually wants to cut through the land onto the other side of the river. It will, in time, over lots and lots of years, build up this force, and it will eventually cut through that land. What will then happen is this part of the river that we're seeing right now, that I'm standing right in front of, will actually turn into a lake, and it will be cut off from both its feeding and depositing end. So we won't have to worry about any barges coming into this section anymore, any boats. It'll turn into more of just a lake. Its source of water would then be any runoff of the hillsides, any sort of groundwater, and then any precipitation. Hello class, welcome back. We're going to talk about some more of the properties that we talked about inside so I can go more in depth with them. This is a picture of the Monongahela River. Where we were standing before was over here at High Point Restaurant. So we were looking at the river this way. So where I talked about it being flat, which was our depositional environment, our point bar, was where Cal-U was. This side was the hill that we were talking about, our erosional processes. So let's go ahead and label those. So as the river flows through, this is going to be its path where it is the fastest. It's going to be extremely slow on this side. So what's it going to do? It's going to deposit its sediment on that side, which goes ahead and tells us again that it's flat. It's going to go onto this side and erode away and cut into this bank. As it cuts into this bank, it's going to keep on going, keep on going. It'll actually erode it so much that it'll connect with this side. Let's look at those properties on this side. If the river comes around this way, what would be our slowest point? Correct. It would be over on this side. This would be our fastest point. So it's going to go this way. It's going to cut on this side. What's then going to happen? Right. Our river is then going to be diverted. It's going to cut off this section here. And our river is going to follow then this path. This would be what we had talked about earlier, our Oxbow Lake. Where the only incoming water to this portion here would be any sort of runoff, groundwater, or precipitation. All right, class, now we are going to talk about how do we order these streams. As scientists, we always have to classify something. Some things we've talked about in class is properties of scientists, what we like to do. Number one thing, we all know we like to have controversy, so we like to prove each other wrong. Another thing that we like to do is we're extremely organized. We have to have stuff in a way, in an order, that we'll understand it. So of course, we're going to then classify our rivers. The way that we do this is called stream ordering. The way that I like to think of it is as a tree. A tree has its trunk, okay? That would be your main stream. That would be the ending product. And then all of the branches coming into that trunk of the tree would then be all of your tributaries. We're going to talk a little bit more about this inside, and I'll explain it a little bit better for you. All right, class, so now we're going to talk about stream ordering. When we were outside, I had said how the streams and rivers we have to order them. We have to classify them because we're scientists. We like things to be in order. I've compared it to a tree. Okay, the trunk of the tree being our main river. So let's put our main river down here. Okay, then we're going to have tributaries to this river. For example of this, the Colorado River, such a huge, massive, gigantic force of energy, huge river, does a lot of erosional processes, carved out our Grand Canyon. That river started as a trickle in the Rocky Mountains. Okay, so in order to do that, in order to order that, we order all of our tributaries. So this being our main river, let's say we have all these tributaries that come into that river. Okay, and let's say this is our top tributary. Okay, so we're going to label our top tributary, our initial tributary, 1. Okay, if one goes into another tributary that has nothing else connected to it, no other stream going into that one, we're going to give that the number 1 also. So go ahead on your papers and go ahead and start to label your streams, all the number 1s. Okay, I see all eyes on me, so we're going to move on. I now labeled all of our number 1 streams. When 2 streams go into 1, we're going to call that an stream order 2 stream. So we have a 1 order and a 1 order. It's going to go into this one. This one has no other stream going into it, so it's going to stay a 1. But right here we have a 1 and a 1 going into this one. This one's going to be a 2. We have a 1 and a 1. This one will be a 2. Go ahead on your worksheets and fill that in for me. Okay, see all eyes on me? We're going to move on. Now we run into an issue. This is our main stream. However, we have a tributary of a 1 coming into it, a tributary of a 2 coming into it, another tributary of a 1, and another tributary of a 2. So how do we label our main stream? Any ideas? Correct. It's going to go ahead and take the place of the highest stream order. So this stream would then be labeled a 2. That's how we order our streams. Alright class, so today we have learned a lot of different things about our river systems. We have learned why rivers meander. We've learned some processes of fluvial systems. We have learned cut banks. We have learned point bars. We have learned depositional environments, the points in which a river will erode. We have learned its speed, where it is at a faster speed, where the river is stronger. We've learned over time what will happen with the river, how it will cut through the earth actually and go into more of a straight path. So I would like you guys to take out those pieces of paper that we talked about in the beginning of class, where I had you guys make some observations of the Monongahela River. Were anybody's observations the same as what we just talked about in our notes? Great. So you guys did know this material. You knew what we were talking about. We just put a scientific name to everything. Great job.
This one's for you, Artie.